In this video, we're going to start extending our map system with a number of methods that will allow us to build our world map. Eventually, we will begin using these methods to procedurally generate buildings and paths, but to begin with, we will manually use these methods to test out the map. The first method we are going to create is one that allows us to set the cell types for each position on the map. We will call this method SetCell, and we are going to overload the method so that we can set the ground type, structure type, and overlay type all with the same method based simply on what enum type we pass to the method when we call it. We are going to need to define two other methods that will help us write the SetCell method. First, we will create a method that allows us to check whether a position is actually on our map. We will use this method to prevent other methods from trying to retrieve a cell that doesn't exist in our map. To write this method, we will define two local Boolean variables. The first variable will check whether the x value is within the bounds of our map, and the second will check whether the y value is within the bounds of the map. Then we will only return true if both Boolean variables are true. The way we've defined our map, the values can be equal to the size of the map and still be within bounds. Remember, we've defined our map so that the origin 0, 0 is at the center, and the map extends in both positive and negative directions out to the map size. We will also begin the practice of writing two versions of many of our map methods. The first version will take an x and y component separately as int values, and the second version of the method will take an int2 vector as the position. We will maintain a pattern of writing the logic in the method that takes the x and y inputs, and then the vector method will simply call the other method by separating out the two components from its vector. This is a convenience that will often be useful as we begin doing more complicated things with the map, and we will repeat this pattern with many other methods. We can now begin writing the SetCell method using our new OnMap method. We will first check to make sure the position we are trying to set is actually on the map. If it is not, then this method will simply do nothing rather than causing an error by trying to access a cell that doesn't exist. One reason this is nice is because if we change the size of our map and it causes buildings to fall off the edge of the map, they will simply be cut off rather than causing a bunch of errors. Now, to finish the SetCell method, we will introduce a GetCell method that allows us to get a reference to the cell at a specific position on the map. It might seem like a good idea to also check if the position is on the map in the GetCell method, but we will handle that problem in a different way when we overload this method. And we may even come back later and simplify the SetCell method based on how we write the overloaded GetCell method. To proceed with the GetCell method, we are going to need a method that returns the ID when we provide the vector position. This will be the reverse of the ID to position method we wrote earlier. We will call this method positionToID. The algorithm to get the ID is simply x plus y times the width of the map, but we once again need to account for our origin at the center by adding the size of the map to each coordinate. This will ensure that both x and y are positive values, because our coordinates run from minus world map size to plus world map size. We will continue our pattern of overloading our methods with a vector version as well. Now we can finish the GetCell method by using this new method to retrieve the ID associated with these x and y coordinates. Once we have the ID for this position, we will access the cell using the world map list of cells. Now we can finally complete the SetCell method by using this new GetCell method. If the position is on our map, then we will get the cell and then we will update the ground type for the cell based on the argument that was passed in. Let's test out this new map method by changing one of the floor tiles we set up in the GenerateWorldMap method. We will change the cell at the origin of the map, 0, 0, to be the other type of floor tile. We can then run the simulation and check to make sure the tile at the center has been changed. This is exactly what we wanted to see. Now, let's overload our SetCell method so that we can also change the other layers of our cells using the same method. We're going to reproduce the same method, but then simply change the last argument to be of a structure type. This will overload the method based on it having a different signature or list of arguments. We can copy over the exact same logic and then just change the line where the cell's type is updated. Then we'll follow the exact same pattern to also create an overload for the overlay type. We're going to do one more thing to the StructureType method simply for convenience. Since the structured layer is going to contain things like walls and other obstacles, we are going to set the solid property of the cell to true every time we place a structure on the map. This may not always be what we want in practice, but it is going to be helpful much more often than not. Now we are going to test out all of our SetCell methods to make sure everything is working as expected. We will make a few calls to the StructureType overload right beneath the line where we set the center tile to floor 2 using our ground-type SetCell method. Then we can press play and check to make sure everything is being placed on the map correctly. Now we can see a few walls have been added to the map. You might want to do some more testing at this point to get a better sense of how the coordinate system works with our map, because we'll be building up much more complex map methods using these same basic methods, and it can be helpful to get a good sense of how the map is laid out. The next thing we're going to do is overload our GetCell method with a version that gets a cell based simply on its ID value. We can then use this method in the first GetCell method we created earlier. When getting a cell based on its ID, we can check whether it is on the map in a slightly simpler way. Because the ID is a one-dimensional value, so we only need to check whether it sits in the range from 0 up to the total number of cells in the map, which is just the area of the map. We might go back and simplify the SetCell and OnMap methods later based on this GetCell method's bound check, but for right now we'll leave them how they are. We will also create the vector overload of the GetCell method now. This method will maintain the same pattern of breaking up the vector into two components and calling the coordinate version. Now we can complete our testing of the SetCell methods by adding some calls to the OverlayType overload to make sure that they are also working correctly. It looks like all of the overloads are working perfectly. That's all we're going to do with the map building methods for now. In the next video, we're going to introduce the new Unity input system so that we can allow the user to move around the map before we get further into developing the simulation.